Now let's say I have decided to examine the impact of changing interest rates on this model. Currently, I'm told that the interest rates that I should be using is 8.5%, but let's say I was also told that the interest rates could be anywhere from 7% to 16%. If I want to figure out how sensitive the model is to that particular change, I can look at the NPV at 7%, and I can look at the NPV at 16% and come up with a decision. But it would be better if I could try out several values between 7% and 16% and then see how the NPV is changing, whether NPV is changing linearly or not within that range. One way of doing that is change the value in C12 one by one from 7% to 16%, perhaps let's say with increments of 1%, and observe how the NPV changes. But in fact, that could be tedious, especially if you want to try out several values for this parameter. Excel has a faster way of doing this using something called data tables. Next, we will illustrate how we use data tables. So, in this particular data table, I'm going to see how a change in interest rates affects net present value. So, the lowest interest rate I'm interested in is 7%, and I want to bring it up to 16% by increments of 1%. So I type in the first two, and then I'm going to go ahead and copy paste this. So these are all the values for interest rates that for the interest rate that I would like to try out. I'm just going to label this to be a better spreadsheet engineer. Now I'm going to create a table here, an automatic table here, and in this table, each time I change the interest rate, I'd like to see how the net present value changes. So at the top of the table here in cell K3, I'm going to make a link to NPV. So what I'm going to tell Excel is try out the values 7% to 16% one by one in cell C11, and for each new parameter value, tell me what happens to H14, the net present value. So I'm gonna make this a little bigger. All right. So in order to generate the data table, here's what I do. First of all, I need to make sure that I have a table like this, where the first column is the values I want to try, and on top of the second column, I have the value that I'd like to observe. These are values I typed in. This is a formula that refers to H14 here. Then you highlight the table, you go to the data ribbon. In the data ribbon, you go to what if analysis. Under what if analysis, you choose the data table option. This is a fairly terse dialog box. It asks you, do you have any input cells in rows? Do you have any input cells in columns? Well, if you look at our table, our input values are in a column. So we're going to go here. And it asks you, when I pick up a value from this column, which cell shall I put it into? And well, each time I pick an interest rate, I would like it to be plugged into C11, so I'm going to choose C11 here. I need to make sure that C11 is a cell that does not contain a formula. It should be a cell that has only a value in it, so that Excel can override it with other values from this column. I don't need to enter anything in the row input because I don't have any row input parameters that I'm specifying. On the row, I only have my output value. And then I hit OK. Let's make this bigger and format it a little bit. All right, so what is this showing us? It's telling us that at 7%, our net present value is almost $1 million. At 16%, our net present value is almost -1 million. And the net present value keeps decreasing from 7% to 16%. Now, what is good about this particular data table? First of all, if somebody tells you, oh, you know what, I'm not quite sure what the interest rate is going to be for the next 10 years, but I know that no matter how much it fluctuates, it will never be more than 10%, then you can safely say to that person, you know what, then we don't need to worry about this investment, it's always going to be in the clear. Or if somebody tells you, you know what, I have no clear idea what the interest rates are going to be in the next 10 years, but I know that they will never dip, let's say, below 13%, then you know that this is not a good investment for you. So within certain ranges, the model is very insensitive to what the interest rate is going to be. But if somebody comes up to you and says, you know what, the interest rate in the next 10 years could be anywhere from 9% to 13%, then as you can see, there's a big switch in your decision. You may buy the building here and you won't here. So if somebody comes to you and says, well, the interest rate is going to be anywhere between 9 to 13%, then if you have extra time, extra money, extra energy that you can put into figuring out what the interest rate could be exactly, or a more precise interval, then it falls onto your shoulders that you spend that time, energy, money to get a more precise estimate, because that range of 9 to 13 is a range where the model decision will switch from one to the other. This table we have generated is called a one-way data table. It lets Excel generate an automatic table that shows you how a particular model output is impacted by changes in a single parameter. The next thing I want to show you is, well, what if the question that you want to look at is, where is that break-even point? I know that at 10% I'm making money with this investment. I know that at 11% I'm losing money with this investment. What is the magical interest rate that gives me 0 NPV? Now, in order to find what interest rates give you a net present value of 0, you can simply do a trial and error between 10 and 11% and try to reach an answer. But Excel has an easier way of doing this. Here's what you do. You go to the data ribbon. In the data ribbon, you again go to the data tools portion, choose what if analysis. Under what if analysis, you choose goal seek. Goal seek asks you a few questions. It says, which cell do you want to set to a value? Well, I'd like to set the net present value to the value 0. And it asks you, which cell would you like to change to reach this goal of net present value of 0? I say, well, I want to change the interest rate. So what you're doing here is you're saying, try different values of the interest rate, C11, so that see if you can find a value in C11 that will give me 0 for H14, net present value. And then you hit OK. And if there is a solution to your question, sometimes there may not be, it gives you this answer that says goal seeking found a solution. And if you hit OK, you will see that 10.6, or if you look at more precision here, there's 10.599. If the interest rate is 10.6%, then the net present value is 0, which means you're breaking even. So again, you can interpret this in another way. If your interest rate in the next 10 years is always 10% or less, then you will make money for sure. And if your interest rate is always 11% or more, you will lose money. Now, what if I was interested in how the NPV would change if I had two uncertain parameters? So I have created a one-way data table that lets me look at how the net present value changes when I change one parameter. Can I do that same analysis if I try to change two parameters at once? And the answer is yes. Let me first go bring back the interest rate to 8.5, which was our base case. What I would like to do next is change the interest rate from 7% to 16%. In addition, I'm going to look at how the occupancy rate might change. And I'm going to try 3 different values for occupancy rate: 80%, 90%, and 100%. So let's go here. I'm going to clean this up first. So I want to do interest rate of 7% to 16%, 7 to 16%, and then I'd like to try occupancy rate of the rates of 80%, 90%, and 100%. So earlier I had created a one-way data table. Now I'm going to create a two-way data table where I'm changing the interest rate, I'm changing the occupancy rate, and I'd like to see how the NPV changes. In a two-way data table, you put one set of parameter values in your column, one set of your parameters in one row, and then you put the NPV, or the value that you'd like to observe from the model, at the top left corner of your table. So I want Excel to generate an automatic table for me that will change the interest rate here, that will change the occupancy rate here, and then give me results. By the way, I should also bring the so in order to create a two-way data table, first I create this empty table. Then I highlight the entire table. I go to the data ribbon. Under the data tools portion, I go to what if analysis. Under what if analysis, I choose data table. It says, well, what are your input cells in the row? So I have in this row 80%, 90%, 100%, which will go into C13, the occupancy rates. Then it says, what are your column input cells? Well, in this one column I have interest rates, so each time I plug a value here, I need to put it in C11, and then I hit OK. Let's format this. Here we go. When I get a two-way data table like this, especially if I'm interested in where I'm in the red and where I'm in the clear, I'd like to conditionally format this. So I highlight the whole thing and say, well, show me where the value is less than 0. That way I know exactly where I'm in the red and where I'm not. So what can I read from this particular data table, two-way data table? Well, this tells me that if you know your occupancy rate is going to be 80% or more, then as long as your interest rate is 8% or less, then you don't have to worry about this decision. You will always make money. Or you can look here. If your interest rate is 11% or more, then even with 100% occupancy rate, you're always going to be in the red. So, for example, if somebody tells you your interest rate for the next 10 years is going to be 13% or more, then you don't really need to get a precise estimate of what your occupancy rate is going to be. Because at 13% or more interest rate, even at 100% occupancy, you're losing money. So you will always lose money. You don't need to spend more energy trying to get a more accurate estimate of how your occupancy rate is going to be in the next 10 years.